This video is supported by Brilliant. Hey, Marcus Housewithy here. So much to cover today, the latest rundown in Starship development at Boca Chica, and we've also got a fresh Cape flyover from Greg Scott and Fariel providing more fantastic insights into progress in Florida. It has been a few weeks, so lots to check out there. Obviously, a lot to talk about with SLS since the scrub almost a week ago. There is a new plan of action. We have a SpaceX rideshare flight. Yes, it is time again to dive into mission inception. Rocket Lab teams up with MIT to help explore Venus, and a lot more.
Okay, Neil, we can see you coming down the ladder now.
Kicking off this week at Starbase's launch site, where once again we have another round of testing and all the preparation work that went along with it. First of all, last weekend, Ship 24's replacement Raptor vacuum RVAC 115 made its way from the build site to the launch site, and that night it was lifted and fitted. SpaceX has also once again added more pipework into the orbital launch mount, making it even more complex. Seen here is large piping actively being added around the launch mount. The hope, of course, is that this is all part of a far more beefed out water deluge system to be used for many engine static fires as well as launches. This probably also explains the recent modifications that SpaceX started to convert the old vertical methane storage tanks into water tanks. From what it looks like, the 12-metre water tank still isn't planned to be used anytime soon. Early in the week, the residents of the area received an alert notice, so we knew that we were in for another round of testing. Tuesday came and we were expecting some static fire testing due to there being an overpressure notice. However, it soon became obvious that Booster 7 was not going to perform any testing that day. We knew this because SpaceX had left the work platform up underneath it. Instead, the B7.1 test tank started venting instead as it was being filled with liquid nitrogen. This, of course, is the booster test tank on the Can Crusher, which has undergone quite a few tests recently. Soon after, the lines were pulled tight as it attempted to squeeze down on the tank. The test there seemed to end without any sign of failure, and it was detanked, followed by the road reopening. Now, just as a side note, at the start of that same road closure, 2 propellant tanks left Starbase as captured beautifully by Nick and NASA Spaceflight. These were headed for the old Macy's gun range location, where SpaceX has been completely overhauling their site. It is looking less and less like a gun range now. Thanks to the latest RGV shots, we can already see the tanks being installed here, potentially making this site an engine test facility as was mentioned last year. Amazing shot here of a vertical Raptor test as just captured by Justin Schwartz. Logistically, this makes a lot of sense as this site is only 11 kilometers away from Starbase compared to the much larger distance of 600 kilometers between Starbase and SpaceX's McGregor testing facility. If SpaceX needs to quickly run tests on Raptor engines used in ship or booster testing at Starbase, Texas, they could do it here a lot easier in comparison. Nearby here, we can see where they dropped the nose cone test cage after it was moved away from Starbase. A great deal of groundwork going on all around here to prepare the site, so it looks like this area is going to continue to get even busier. On Wednesday, the Raptor maintenance platform was taken away again in anticipation of more booster action. That kicked off on Thursday at midday. It conducted a super impressive staggered startup long-duration multiple engine spin prime test. Just take a look at that. We were also hoping for a static fire, but that was sadly it for the booster that day. It was depressurized and no further action came there. Never fear though, because some exciting tests were just a few hours away. Over at the suborbital pad, there it was, Ship 24 chilling the engines there just before 4 p.m. Half an hour later, yep, another super impressive multiple engine static fire, which I'm reasonably certain was all 6 engines. Now, what's this though? Yep, oops, SpaceX managed to get quite a grass fire going there too, with the fire continuing to spread for hours. The fire department was involved too, but why did all this happen? After all, SpaceX have spent lots of time removing as much foliage as possible around the area. As pointed out by Zach here in this perfect RGV shot, they didn't have permission to remove all of the close by foliage which could have led to some of that fire spreading. Now, in reference to an article regarding the hydrogen issues of the Space Launch System, Elon Musk explained why SpaceX chose to use methane for the Raptor engine all those years ago. In fact, something I didn't know is that Raptor started off being designed as a hydrogen-fueled engine, but they had switched it to methane shortly after. As stated here, methane provides the best combination of efficiency along with ease of operation. That is for sure. Liquid hydrogen is just so tricky to work with given the ridiculously cold boiling point. When it comes down to it, the delta V difference between hydrogen and methane is actually quite small depending on the mission. That is because the methane tank can be much smaller and insulation isn't anywhere near as big of a deal, if it is even needed at all. Over at the build site, let's first have a look at the upcoming nose cone barrels. In one of RGV's recent flyovers, we can see these two nose cone barrels right here. This one on the right was assigned to Ship 26, and the left one we originally believed to be Ship 27's, but that was not confirmed. We can see this in Brendan's latest diagram here. Thanks to some of the findings here by the Ring Watchers team on Twitter, we are actually now assuming Ship 27's payload barrel has passed the production progress of Ship 26's. We can see the one on the left, originally Ship 27's, has received the header tank pressurization lines and what looks like other additional pieces related to the Starlink dispenser. The other barrel does not, and this may well mean that Ship 27's payload barrel may actually be reassigned to Ship 26. Right inside the tent, we can also see Ship 26's nose cone, which has now been fully stripped of tiles. We'll be keeping an eye on this one to see if the forward flap hardware remains attached or if that is covered up. Future booster production is continuing along nicely as the Common Dome section, possibly for Booster 10, was brought out of the tents this week and flipped for stacking. During its flip, we could see that this is indeed the same section that we saw 2 weeks ago using the new smooth dome. So it seems that SpaceX could be very confident in the design of these domes for future vehicles, even though the E-Dome test tank hasn't completed any major testing. Okay, so after several weeks of no flights over the Cape, Lab Padre and I finally got Greg Scott and Fariel back up into the air over Florida to check out everything that's been happening here. First off, the Star Factory has come a long way since the last aerial views. The first segment has now nearly completed receiving cladding on its roof, as well as a majority of the cladding on one side. In fact, the second segment is progressing really quickly too. The roofing segments to be lifted next are already being rapidly assembled on the factory floor. Over at the high bay, here is the LR11000 crane in all its glory with a red tip. Given the love of weird nicknames for things at SpaceX facilities, Rudolph seems quite appropriate here. Yeah, terrible, I know. It looks like the team is staging a lot of the hardware right beside the high bay to start with this construction. At the entrance, they're setting up these prefabrication pads, something that we've seen them do before at Starbase in Texas. Close by, we can see the 9th tower segment looking like it's ready to roll down to be stacked. If you look very carefully, you can even see the sheave included there. Now, right next to these, SpaceX has fully reinstalled stands for 5 pre-assembly jigs to kick off construction of a third tower, we assume. There is a load more tower hardware right next to some of these jigs, so it's going to be interesting to see what rises here next. The tower arms and ship quick disconnect arm work has come along further, and hydraulic accumulators have been installed on the carriage, which we can see at Starbase Texas as well, so lots going on here. Over at the Historical Launch Complex 39A, and wow, we've got a great new perspective here. We can see that the LR11350 crane is now vertical again after it was extended for the second time, all to lift the final 2 parts into place. Segment 8 is close by, ready to be lifted, and here we have the mystery tank, which looks like it's reached peak height with just one big ring section and the now fully finished dome for the inner tank remaining. At the tank farm here, it looks like we've gained 4 kettle boilers and footings for about 5 more still remain. Not far off, we can see 4 horizontal storage tanks in a staging area, and, well, that is one way to keep your car shaded from the sun, isn't it? Over here we have an updated shot of the methane tank farm, and the huge propellant sphere has received a much needed lick of paint. Note that the kettle boilers are also present here, as well as footings to expand the horizontal storage tanks from 4 up to 6. All of the required cryo pipework is a huge job in itself, but it is steadily being built out to the Starship Tower. Thanks a heap to Greg and Fariel for the flight and for the patrons supporting them here with us on Patreon. This community really benefits from your support there, so if you can, it goes a long, long way. We'd love to get them organised more frequently in the future if possible. Appreciate the help there, just as I do with you supporting my little channel here. It is most awesome of you. Right, now, shortly after last week's video went live, we learned the fate of the second launch attempt of NASA's SLS rocket. It looks like my segment from last week maybe didn't age that well after all. Shortly after beginning tanking operations on the core stage's liquid hydrogen tank, engineers this time detected a significant leak, once again at the quick disconnect assembly. NASA attempted to use the previously successful method from the first launch attempt to fix the problem. They tried reseating the seals by allowing them to warm up and cool down again. That sadly didn't work. They then tried using pressurized helium from ground systems to push the assembly back in place, making a tight seal, but that was not happening for them either. Now, like me, I'm sure that you are also looking forward to finally seeing the giant orange beast fly, but it looks like we're going to be waiting just a little bit longer. There are many dynamic variables at play here if SLS is to fly without being returned to the VAB. It all depends on the quick disconnect fitting repairs which NASA has attempted to do at the pad. This would be ideal given that they could test the seal using liquid hydrogen, something that can't be verified back at the vehicle assembly building. In fact, for this very reason, NASA will be doing a tanking test to verify everything is in proper shape. This is currently scheduled next week on Saturday. We of course then also have the other issue. The Flight Termination System certification has now expired. NASA has submitted a request to the Eastern Range to extend the certification period for the batteries. Let's hope that they get it, otherwise it will mean a rollback to the VAB anyway. Along with all of this, a rollback could simply just be down to simply needing to protect the launch vehicle from harsh weather conditions. If everything goes to plan on the 17th of September, the next launch opportunities are on the 23rd and the 27th of September. I sure hope NASA can get everything fixed, but later opportunities up to October the 4th are probably going to be more realistic at this point. We had another Starlink mission ready to fly last Sunday aboard Falcon 9, this time though a slightly different payload on board. Enclosed in the fairings were 51 Starlink broadband satellites, but an added passenger as well. Liftoff occurred right on time, marking the 95th launch from Pad 40, and there roared the Falcon 9, rapidly ascending into the night sky, this booster on its 7th flight. Interestingly, the first 2 flights for this booster was as a Falcon Heavy side booster before it was converted to be flown as a Falcon 9 core. We had the typical rapid sequence of events taking place there soon after: main engine cutoff, stage separation and fairing deployment, exposing the payloads to the vacuum of space. The booster there safely made its way back to Earth with another successful landing on the drone ship. Just read the instructions. Absolute bullseye there as well. So this mission was also a rideshare for spaceflight and their orbital transfer vehicle known as Sherpa LTC-2. This one also hosted a payload of its own for Boeing with their Varuna technology demonstration mission satellite, a payload inside a payload, a mission inception if you will. This is to test communications as part of a pathfinder for a potential 147 satellite broadband constellation. About 49 minutes into the mission, Sherpa departed the second stage at around 310 kilometers in altitude above the Earth. The Starlink satellite deployment soon followed, with both payload departures confirmed on Twitter. Now, unfortunately, when it came time for payload deployments, we have no video to show you. That is due to the lack of ground station coverage at the time, and also because SpaceX have really not been showing the deployments of Starlink lately. The Sherpa space tug then proceeded to raise the host payload's orbit to 1,000 kilometers above the Earth, where it begins to carry out V-band spectrum testing for the next 2 years. At that point, it is going to perform a deorbit burn and bring this demonstration mission to a fiery conclusion. Now, work continues towards an expected launch next week for Rocket Lab and their customer Synspective. This mission, dubbed the Owl Spreads Its Wings, is scheduled for liftoff on September the 15th. Preparation also continued on another front as well, with a recent update here from MIT working with Rocket Lab on the first ever privately funded mission to Venus. This is hugely exciting. Over the past 60 years, of course, we have managed to send a bunch of probes to Venus, but it still seems as though there is tons to discover here. This blisteringly hot planet not only has the highest surface temperature in the solar system, well over 450 degrees Celsius, but also it has a retrograde spin. In short, Venus spins backwards compared to the other planets. It's also worth noting that a typical day on Venus is 243 Earth days long, where its year is actually shorter, around 225 Earth days. This has always interested me because it is so unusual compared to the day-night cycle that we are used to here on Earth. With an insane atmospheric pressure, rain in the form of sulfuric acid, and a temperature that will melt lead, surface conditions among the vast Venusian valleys and mountains are super inhospitable. Believe it or not, however, it is a different story at 50 kilometers or about 30 miles in altitude in those dense yellow clouds. You may recall this announcement back in September of 2020. Astronomical researchers in the University of Cardiff in the UK announced that phosphine gas had been detected in the upper atmosphere, sending the planetary scientific community into a spin. Why? Well, on Earth, phosphine gas is mostly created through biological processes. Could there be life to find on Venus with microbes releasing this gas? Opposing views soon came out suggesting alternative explanations for what was actually being seen in the telescope's spectral data. Sulfur dioxide exists in huge quantities, and other specialists in the field believed that this is what was actually being observed. Lucky for us, scientists may soon hopefully get a more conclusive answer to this phosphine gas question and other potential mysteries as well, thanks to these potential upcoming missions. We could have a treasure trove of data if Rocket Lab has got anything to do with it, especially with the low cost of such a mission potentially under $10 million. Now, we have known for quite a while that Peter Beck has got a huge interest in using their multi-purpose Photon spacecraft for a mission to Venus. He was contacted by MIT some time ago with an exciting opportunity to conduct a potential launch in 2023. With a small probe currently under development, it is hoped that a launch could occur around May of 2023, a similar style of mission to Da Vinci I'm showing here on screen. Once there, this little probe will have around 5 minutes to run its tests and measurements using an ultraviolet laser on droplets in the cloud layers to measure the composition of the molecules there. In essence, this test is going to be searching for organic particles. Now, before we get too excited, it is worth noting here that even if a positive finding here is found, it doesn't necessarily mean that we have found proof of life on another planet. It would initially simply add more weight to the idea that Venus has the potential of including a habitable environment. So yeah, if the team at MIT can have the probe finished in time, thanks to Rocket Lab's low cost and launch capabilities, there is every chance of a Venus mission and some new exciting data to explore late next year. The alternative is that America and Europe send probes to Venus later this decade. In comparison, that data would probably not be available until the early 2030s, so this new opportunity is very exciting stuff for sure. Now, hopefully quite soon after this video goes live, we're going to see the very first test flight of the RS-1 rocket by ABL Space Systems. Obviously, being a demonstration mission, this is going to be an exciting one to watch. More on that in just a moment, but let me just thank today's video sponsor, Brilliant. Are you looking to pick up some new knowledge in math, science, and computer science? Perhaps wanting to brush up on some existing knowledge? As I'm sure you would agree, there is no better way to learn something than to run through exercises with beautiful visual examples that explain the why behind the subject. Brilliant is the best way to learn interactively, and they have got thousands of lessons including exclusive new content being added every single month. In particular, I have been super impressed with the brand new Quantum Mechanics partner course right here. This is really amazing stuff. I've always had a big fascination with the crazy quantum world, and being able to play around with exercises such as destructive interference is really quite intuitive. In fact, a mind-blowing phenomenon shown with the famous double slit experiment has interested me for years. The interference pattern created even when firing one photon at a time demonstrates that a very intriguing quantum understanding is needed. Does light behave like a wave or a particle, or both at the same time? Well, you can find the answer out right here. It really is incredible the impact that you will notice learning just a little bit every day. This is all about Brilliant helping you to be a better thinker. To get started for free, visit brilliant.org/MarcusHouse or click the link below there in the description. The first 200 will get 20% off Brilliant's annual premium subscription. So yes, in early July, ABL performed the static fire test of the first stage to test out the startup sequence and the engine performance. That was all reported to have gone very well, so it all comes down to the first test flight, doesn't it? As with any rocket launch, there are thousands of things that need to go right for a success, and only one thing to go wrong for a failure, so we've got our fingers crossed here. The rocket itself is almost 27 metres tall. If we compare that to Relativity Space's Terran 1, that is about 35 metres or so. The Terran 1 can blast almost 1,300 kilograms into low Earth orbit. ABL here suggests that the payload of the RS-1 should be able to fairly closely match that. So yes, they've got quite similar capabilities. ABL also have got well over 55 missions planned on their manifest, forecasting well into the future. That is not bad for a rocket that hasn't yet flown, although Lockheed Martin is a key customer, so pretty safe bet that funding is not going to be an issue. For this first mission, it is going to attempt to place 2 CubeSats into low Earth orbit. Those satellites are part of the US Air Force's Chameleon constellation, so best of luck to everybody for this one. It is going to be launched from the Pacific Spaceport Complex in Kodiak, Alaska. Should be a real fun one to watch. So yes, you are all caught up there on yet another week of space goodness. If you want to support what we do here on the channel, remember to simply share and inspire those around you that may not be taking notice or even understanding the significance of the space industry right now. We are at a true tipping point as all of these commercial options open up, and support, I think, worldwide is really important. Thank you very much to you though, there wonderful subscriber, or maybe a potential subscriber. Without you, there is really no channel, so I can't convey just how much I appreciate you being right here. If you happen to be a super fan of what we do, like all of these awesome people, the Patreon link is right there, which gives you earlier ad-free access to these videos, and of course access to our Discord server as well. And if you want some new gear because your old clothes are getting a little past it, well, that is a terrific way to support too. We're still getting loads of great comments on the deep dive video that we did on nuclear and future propulsion if you missed that one the other week, and we're actually working on a brand new deep dive right now, which is only a few weeks away. Really can't wait to see what you think of that one. Thank you everyone for watching. I'll see you all in the next video.